Now let us do certain numericals in order to understand how we can use this pH scale. The question is, find the pH of 10 to the power minus 8 molar HCl solution. The HCl given to us is 10 to the power minus 8 molar. See, this concentration is very small. If we have to find out HN's concentration, we will say it is 10 to the power minus 8 molar, which is actually is from HCl. But now we have to add 10 to the power minus 7 molar from the water also. Because the total number of H plus ions will be the sum of the what they are already available due to the dissociation of water and whatever which has been provided by the HCl which we have added. So now the total will become, if we take 10 to the power minus 7 common, it will become 1.1. So we can write it 1.1 into 10 to the power minus 7. So therefore your pH will be minus log of 1.1 into 10 to the power minus 7, which will be minus log of 1.1 plus, it will become, minus log of 10 to the power minus 7. This will become 7. So it will be 7 minus log of 1.1, which will be actually somewhere 6.98. So remember, it's not in any case more than 7. HN's concentration can never go beyond 10 to the power, never go beyond 7. Because we know we have to add the concentration of the HNs which are obtained from water, and in that case that will never make it to go beyond 7. Another interesting thing which we have to notice in this case, in what all concentrations we have to add the HN's concentration which are already there from the water. See, always remember, we usually do this addition of the HN's concentration which are obtained from the water whenever we find that it is actually up to the first place of decimal. It means usually from 10 to the power minus 6 molar to 10 to the power minus 8 molar, in between this concentration of H ions or OH minus ions, we add H ions or OH ions of water. This is most important thing which you have to remember.